can coordinate best, exactly as you see on this page, exactly along the whole value chain from production to facility management. And thus, let me explain some use cases already in the production. It's about using control sensors, optimizing the production and the efficiency and the effectiveness of machinery, of tools, of labor, but also smart devices checking materials for cracks and moisture, and thus impacting the efficiency of the production, reducing downtimes, reducing production rejects, and enhancing quality along this production activity. When we come to distribution, I mean, the most obvious one is using transmitters sending information about where the goods are. You all know the Amazon style of tracking. This has reached also the construction industry, starting by the cement industry, where the ready-mix concrete is mixed and then transported on construction site. A project manager on production site sees already when the new silo of ready-mix concrete will arrive to continue then the work, and thus GPS trackers make this possible along all kinds of logistics within the construction itself, right? When it comes then to construction, we certainly come back to this in more detail in a moment. It's about interlinking people, labor, machines, and tools and materials at the construction site. Certainly also driven by building information modeling. I mean, the state-of-the-art planning, and in the future maybe also the backing of each construction site in a digital mode to optimize the correspondent flows, activities, timing, quality, to at the end of the day be very efficient by applying, say, a culture which exists in all other industries. Take, for instance, automotive, where we have just-in-time delivery of material, which is then built in and assembled on the line. Here it would be really managing the construction site in this detailed, just-in-time way, understanding what machines, what vehicles are using what energies are full, and correspondingly optimizing it. But as said, we'll come back to this in a moment. And last but not least, of course, IoT is also a very hot topic for facility management to then enable the energy efficiency in the buildings and the smart usage of all kinds of resources by sensors, smart meters, all kinds of smart connected devices, right? To also then predict maintenance, to act before you have a water damage by simply getting information by sensors that pipes are getting wet, also from outside, but also managing then a building from the bottom to the top with its energy, its lighting, its activities, its security activities, and whatsoever. If we now focus on the next page on our core topic of today, the IoT usage in construction. Please, Stephanie, go to the next page. You see that a construction site and value chain as of today is characterized by various pain points which are costly and drive risks. One is, for instance, misplanning of material. Did you know that around 15% of the material which was planned in a construction site either is is damaged by weather, or it's simply damaged by construction activity, is stolen or whatsoever. By simply planning better in a digital way the material you use for production, a construction site, and also enable a secure, a just-in-time delivery of this material, you can already save 10 to 15% of construction material in an average construction site. But also inadequate project management, inadequate timing of subcontractors, inefficient communication or misunderstanding between stakeholders, insufficient security, right? Insufficient or shortage of skilled workforce. All these are really heavy pain points which make a classical construction project lengthy, costly, with lots of idle times where people, machine, tools, materials are not adequately used, coordinated to then increase efficiency. That's a bit the starting point where IoT and digitization of the construction site can help off in the future. We go to the next page, please, Stephanie. You see some very simple, typical IoT activities. You see on the top the classical process steps of a construction project, starting with the financing, the management, the planning, design, the building, execution, and the facility management. The new intelligent construction site starts already with the management and especially with the digital planning and design by the correspondent planning tools such as building information modeling, where you as an architect or a technical planner, or then supported by a general contractor, can plan your building or your infrastructure in a digital way, in a very detailed way, also defining exactly what materials and even from what suppliers and what technical characteristics can be implemented, which will then represent a digital twin. And of course, you can assume also as an insurer how attractive this is, that you can then track the quality and the built-in materials over time and compare this to the original planned digital twin. This digital twin will be then the single source of truth for all contractors, subcontractors along this construction projects. You possibly know, all the people who have done some work in the construction know that till now it was a work on a multitude of two-dimensional plots, printing documents, which best possibly were then integrated back into one paper sketch. The future is to gather all this information from the architect, but then also cross-check, correct it from the general contractor, and bring in the know-how and the corrections from the electrician, the installer, the drywaller, whomsoever is working on this, and gather this in a BIM data cloud, in a digital cloud, which will be the backbone also for all kinds of IoT, which you then see on the below level, the classical IoT activities, devices of machines, robots, drones, but also in the future, modular construction, three-dimensional printing, just-in-time delivery. All this is, let's say, the action field of IoT on construction site. And at the end of the day, we are talking about interlinking people with their labor, with their planning, material to come in just on time at the desired quantity and quality, tools to find them simply by simple IoT devices on a usually chaotic construction site, but also enabling then a best possible usage of them, not to have some of the tools just lying around, but using them as asset and managing them as asset, and last but not least, also all kinds of machineries or construction vehicles which use fuel, often but by far beyond the necessity of the construction site, and all this can be in the future steered and analyzed by a digital backbone and all kinds of IoT interaction. Right. This brings me on the next page, Stephanie, to then a lot of IoT related technology classes which we see in construction. If I may start from the core of my onion, let's say, we see three major market trends which drive construction 4.0. It's first of all the interconnectivity, of course. IoT is about interconnecting people, devices, machines, materials, and tools. But also it's about automation and usage of all kinds of construction technology, and it's about big data. These three trends drive the digitization and the IoT on the construction site and along the construction project, right? And within these markets trends, you see after three different colors, if I follow a bit the interconnectivity, it's about cloud computing. It's about admin platforms, right? It's about digital twins. It's about building information modeling. It's about IoT itself, thus the sensors, the drones, the tracking possibility. But then in each of these technology clusters, also very specific technologies such as project management tools, blockchain, smart contracts, digital biddings, just to name one. I mean, blockchain itself in construction is worth an own workshop, because you often have the problem that material gets built in spoiled, and you find this out some years of a building in, and huge claims appear. With blockchain on construction material, you would automatically identify a history, even who has transported the material on site, via which wholesaler it came, via what supplier it has been produced in what production site, to then bring in this digital backbone all this information and enable nicely the usage, the analytics of the data, and the steering and optimization of each of the construction projects, which for today is still visionary. Not many of big projects are professionally managed by all kinds of IoT related technologies, but we see a lot of potential here and the future. Let us go on the next pages, and I will hand over to my colleague Carsten to bring across some of these trends and technology clusters with some of use cases better.
Yeah, I think we can skip this one. This is more of a definition of Kai, I think, can you mute? I think I have a backlog for me. I think, first of all, what we try to bring here is an order. I have a...
We hear you. We hear you.
Yeah, but I have a feedback loop myself. Now it's gone. Perfect.
That is better. Mm.
Yeah. Yes. So what we try to do here is bring an order into that big topic of construction 4.0. Kai started by introducing the technology dimension that we had before, this onion, to give an orientation where you are and what exactly you are talking about. And the next step, after having understood which technologies we're talking about and which technologies are relevant, would be to really look at concrete use cases along the value chain, because use cases is typically a level that allows you to really get an idea what's in it precisely and get more practical after having given a structure and some overarching topics to orient and framework to orient yourself. So when we're looking along the whole value chain, what IoT provides is basically more transparency. It helps to optimize planning, and then from an insurer perspective, also very important, it minimizes risks at many points and kind of makes them insurable from an insurer's perspective also, and more from the operators and general contractors side, and also the person who is building actually, or on whose behalf the building is happening. It improves efficiency on the construction side or along the whole value chain. Apologies. And the concrete use cases for financing management, it allows real-time observation of status and progress. So the one paying knows what's happening. And also if you're a bank, for example, you can pay out along building progress, which is quite a cumbersome process today. And if you have transparency generated by IoT, it can help you to speed up and also automate some parts of the chain, because you can directly interlink and there is no manual work to be done. So overall, you have more transparency. There is planning execution security, of course, and less cost, obviously. And from an insurer's perspective, also, if there is anything that is insured in this financing management part of the value chain, you get more data. You can calculate premiums more precisely, and also the extent, for example, to which guarantees are given out on business continuation or on dates when the construction is to be finished can be extended. It looks a bit different on the second step of this value chain when we're talking about planning and design. Here is a lot of the use cases driven by BIM, which Kai already explained before. And this is about synchronization of the plan and what is actually built, because it is very clear what's in there, and the digital twin follows construction progress. So it's exactly visible what's still to be done. And also the feedback loop, very important going forward to understand what has really been built, because today there is quite often deviations on what is actually done on the site versus what was originally planned. And that causes many of the problems down the road. If you're using IoT, you can ensure that this is synchronized and the plan is really what's there in reality. Which obviously is a value in itself if you exactly know what you're buying or what you're building. And going down the road, this helps for automated information sourcing, and also risks becomes transparent because you know if there is a not good material built in, as Kai mentioned before, and even project cost can be insured because you get very much of transparency about the drivers that drive cost or lead to cost deviations from the plan going forward. And typical providers of these, which you can have a look at, is Nemetschek Group, Autodesk, UrbanSim. They are the providers of these BIM models. And if you're interested as an insurer, they would also be the ones to talk to understand on how to actually get the data to then use it for your daily business and operations. Then it looks again different when you're looking at stage 3, the building execution phase. Actually, it has been planned, it has been financed, the design is there, now construction starts. And the site gets live. Here again, IoT helps a lot to understand the status of what is being built real time, which is very important because especially if you're talking about remote construction sites, can be quite cumbersome to really understand it and get the information what is actually been done. And also there is a big upside in knowing what type of material is on the site, which staff is there, which machinery, also which concrete, etc. And when we looked deeper into this, for example, one very practical thing is the tools that are available and the machinery like the excavators, etc. These tend to disappear, to put it politely. And if you're putting IoT devices on those, it really helps to understand where is it and is enough available, because also it's quite annoying if craftsmen come there and the tools are not there and they can't start to build and they have to go home without being able to work. So again here, optimized use of resources, very big topic. Also less incidents and damages if you have control about the progress of the site. And also this, of course, from an insurer's perspective, it reduces claim costs because you have more visibility also on what's getting lost and where risks may appear. For example, also wearables are a topic here. If the staff on the construction site gets too close to the big machinery, the probability of heavy injuries starts, or certain regions of the world where it's quite hot. You can also monitor the physical condition of your staff by using variables and ensure that nobody gets hurt and there is a safer work environment, which is also a big thing from an ESG perspective here, so can also help you here. And of course, again, you can try to ensure more type of risks because data gets available and you can provide solutions on it. And last but not least, step 4 here, the facility management. Kai already mentioned some points. I want to emphasize one more, which is the predictive and preventive maintenance. If you're seeing there is leakage in the pipes, and that could also be just a loss of pressure in the pipes, which is an indication that there is a hole somewhere, and you notice it early on and can check, and you don't have the big water damage that only becomes visible once you see the wet concrete, but you know it up front and you can have it repaired early on. Very similar thing when it comes about freezing or fire can be prevented by this, which of course then down the road reduces maintenance costs and increases safety for inhabitants. And overall makes risks insurable. And you can even think as far as ensuring the uptime of the whole IoT system in the building, because that is in the end very big part of the operating costs. And for example, one very interesting thing that we saw when we digged deeper into this was that you can also manage the air conditioning and climate steering in the building based on this, and just say, okay, we have a weather forecast, to give a practical example, that predicts heat wave 3 days down the road, but today the energy is quite cheap because there is already a lot of sun but not that hot yet, or there's much of wind. Renewable energy is cheap, and you can start cooling down the building already then, just to save the cost. Maybe
received a question, Carsten, which I don't know, which came from Johannes Schmorleitz, whether we just answered it, Carsten, with his explanation on predictive maintenance on with regards to water damages. Yeah. But maybe to add this, maybe because you said big issue in building execution phase. Of course, we have also a huge issue on pipe damages in the construction phase per se, right? But there, in the long run, the idea is also that sensoric around these pipes, also in the construction phase, can avoid and inform machines, people who work around these pipes, right on time before damaging the pipe, first thing, but also this digital twin, which we just explained, is so detailed that we, and also with virtual reality, we see exactly where these pipes are being built, and you can avoid to damage them in a construction phase, especially also in renovation. I mean, in old buildings where nobody really knows where pipes were built. In the future, the idea is that with this digital twin, and imagine me as a facility manager in a huge building with virtuality glasses on, which indicate me directly, based up on the software, where pipes have been built, I can adjust nicely all kinds of works to prevent to just damage them.
Maybe to add up on what Kai that I would say whenever we are having these discussions, the water leakage, water damage case is probably under the top 3 in any kind of discussions that is mentioned, because that is indeed, according to our experience, one of the most prominent and most relevant ones in both operations phase and construction building execution phase. So it holds true actually for steps 3 and 4 on this value chain. And the typical way this can be addressed via IoT is exactly putting some sensors at critical points of the pipe system and measure the pressure. And what you would normally want to see is certain kind of volatility in the water pressure in the pipes, because that indicates, okay, water is flowing, there is sufficient level of pressure, and sometimes the water is used, and that's when the pressure gets lower. And the like, so to say, red flag would be if there is a longer run loss in water pressure on the pipes, because that indicates the typical level when all what's Wasserhahn in English, when all taps are closed.
Faucets, yeah.
When all faucets are closed, normally you would expect a certain level of pressure in the pipes to be reached, and if you don't do this anymore and the sensors notice it, that would put an alert on it, and then you can start looking for the leakage. And if there is you can also define a certain threshold, and if there is too big of a loss in pressure, you could even stop whole water coming to the side, because that would indicate a bigger hole or bigger leak, which can create damage in the short run already. So that is really then the matter of how to calibrate the system. But the overall case we've seen, and that it was discussed quite often, is measure it based on the pressure in the system, sensor based. Johannes, did that answer the question? Or Mr. Schmolleitz? Sorry for calling for name.
We cannot hear him anyhow.
Yeah, I thought just a yes in the chat helps. Seems to be great. Now, going forward, what we want to do is become even a bit more practical and going along all the steps of the value chain as we are presenting them here, and give more specific use cases. I would highlight some, not present all. We'll give you the deck afterwards, but to give you a bit of more feeling what can be done there, and also about the evolution stages that can happen in the use of IoT. So if we maybe go to the next page. Yes, this is exactly the building information model. This is an evolutionary process of how this starts. First of all, step 1 is starting to collect information, really building that digital twin with the aim to reduce planning errors, related cost overruns, and also very important, improve collaboration between all the stakeholders on the site, because there is a multitude of people working there, and maybe you've also experienced that already before. When it comes to avoiding risk, from an overall construction site perspective, it may be very clear that this is a reasonable thing to do. But then if you're looking at individual stakeholder interests, there is very often a imbalance between the personal benefit and the personal cost related to mitigating or avoiding the risk. And building information management systems can be a very efficient manner to also to resolve such kind of conflicts. And then, of course, going down the road, all the operations questions, renovations, surprise avoidance for future owners come into the picture. One more thing to make transparent at this specific use case, one dimension we do not dive very deep into this webinar today, that is geography. When you're working on this in practice, it is also very important to have in mind that the adoption rates of these types of technologies that are enabled by IoT differ quite a lot between different markets. And for example, BIM, the Netherlands are one of the markets where this has progressed quite a lot. So you would find much data on that already there. Home market Germany, excuse me for using that as an example now, is lagging on this one. We are seeing it more and more being integrated in public tenders, but overall adoption rate is behind, for example, the Netherlands or the US, and also some Southeast Asian markets like Singapore are way more progressed on this one. But coming back to what we're presenting here on the slide is also in the second step, so to say, of the evolution. Once there is enough BIM models on single buildings, you can also start thinking about putting up really big reference databases. So trying to put plans and BIM models for several buildings into one database, consolidate them, which can help to enable market standards, because you then know what everybody is building and you see convergence in terms of buildings. And of course, this would also allow to implement automated cross-checks and understand the quality of a model that is planned. Because step one, going back to that one, if you have a good model, that still does not say yet the planning is correct, because there always happen mistakes and faults already in the planning phase, and the reference base could help building automated quality checks on it, and even mitigate the risk further and reduces. And last but not least, you can then also start enrich further data outside the buildings themselves and start the surrounding planning. So if you have a good model of a larger neighborhood with sufficient information on what is being built there, you can also start integrating the public infrastructure like schools, public water pipes, electric cables, etc., to really get into a urban simulation that really gives a whole neighborhood or quarter planning in the last point. And this one helps you to manage risks, but of course can also become a business model in itself if you have sufficient level of data, because there is many external stakeholders, if you really think this through, who could be interested in such kind of information. First of all, of course, the municipalities who are managing these areas. And it is a lot more of what if analysis. If we are building another, for example, charging station for electric vehicles in that area, what does that mean to the electric cables, or how many are there, which probably is quite intransparent today and can have consequences which are not foreseen, which is, I think, or hope is quite clear where the benefits would lie in such a step. But that is more down the road, admittedly, to build these models. Today, it's more about step 1 and 2 when you're looking into practice, and depending on the regional markets, how far this is. Maybe then, if we're moving to the next page, the building and execution phase itself. Here, I touched a bit on that already before. Here we see two types of dimensions where IoT can help. The first of all is the property and the assets itself. Tagging material, equipment, then the use cases here are the prevention of fires, water damage. We have it here again, weather damage, because we're early detecting something, reduces reconstruction costs, loss in value, etc. Then also risk estimates, because you see it early on, what's coming, and business interruption that is driven by this, and then also reduction of vandalism and theft, so supervision of construction sites, because you're seeing when material is removed, there is, for example, what is it called? I think Husqvarna are the ones who actually already tag their toolkits, and you can then follow them. We had Korox before, which is a super interesting startup from Germany, who are helping increasing uptime of the large-scale machinery that is, or heavy machinery that is on the construction site, because you say when to refuel, ways that they see when the engine gets irregularities, so they tell you when to do maintenance, when to repair. And also you need less material present on the site, because if you're having a better planning and you know what's there, you can better move into a kind of just-in-time production, as the automotives are doing it already today. Very uncommon actually for the construction sites. And one more thing just to have in mind here, we're not only talking about construction sites for buildings, but all this also holds true for large tunnels. It holds true for building airports. It holds true for building new large motorways, etc., which come with their own challenges when you're dealing with these kind of construction sites. Because if you're building a skyscraper, you would probably very well know where your excavator is. But if you're talking about 20, 30, 40 kilometers of new motorways somewhere in the desert, there is a value in itself of knowing where the excavator exactly is and not having to start to search for it. And there is also a value in it when you know when to refill, when the excavator is close to where you have the gas tank, and not like 40 kilometers away, because that takes hours and lots of fuel and energy, of course. So that hopefully helps to understand why this is really, there is value in this IoT-enabled information and the real-time tracking on the site. And the other thing is the personnel. I mentioned some health supervision, but at the same time also supervising productivity to understand where exactly people are on the construction site, what are they doing, are they moving in a coordinated manner, etc. Because this also can give quite a big push going forward and help to synchronize workers and machines and becoming more productive. Because one thing we also saw when we analyzed this deeper is that construction definitely is one of the industries that has seen quite small productivity gains in the last decades, especially when you compare it to other more industrialized branches of the economy. And IoT definitely is also a lever to help industrialize these processes. And which goes more into the efficiency direction and not so much towards the risk direction that you're more interested in, if we are not talking about guaranteeing construction finish dates. And then maybe going on the last page of the use cases now to the facility management. If you can flip to the next chart. Here again, we have the strong role of the BIM, as mentioned before, because you have the correct data. It helps you to operate. The maintenance is a big topic on that one. Reducing, preventing damages, detecting them early on, and preventing any bigger risks and business interruptions here. Maybe before, Kai, maybe can we go one slide back? And just open question to the round if there is any more specific questions to these use cases presented, because I think that may have been quite fast, and there is a lot of different application cases in it which you can think about, which is why we also tried to give you this framework in the beginning to help orient, and we just picked some out here. And of course, if there's any questions also afterwards, happy to engage in a discussion on that with you. Otherwise, I would suggest then we can move on, and Kai can do some final remarks on the presentation before we move into open discussion.
Yes, I mean, to wrap up, as Carsten said, we wanted to give you a flavor where this IoT in construction is heading to, with some selected use cases per process step along a classical construction project. But of course, there is so much more. There are so much more use cases which could be shown and developed. In total, we take away as a first point, I mean, IoT will grow. It's growing over the last years in our homes, in our buildings, in our cars, in our factories, and finally reaches also the comparable down-to-earth when it comes to digitalization, down-to-earth industry construction, where compared to other industries can thrive with more impact efficiency, right? By pure coordinating all this this multitude of actors along a project, a construction project, with managing the material flows, with managing tools and machinery. Thus, we see that digitization with help of IoT is growing significantly in the construction from a very low status where it is today, very fast. We also see this confirmed by the activities of the big software companies such as Autodesk, Nemetschek, to mention some, but also the amount of startups in this context, or also the expenditures of the big construction material and wholesalers to invest into digitization to make the construction world digital, right? And all this enabled by the development of the technologies which we mentioned, mainly BIM, building information modeling, driving this. But it does not mean that BIM will be the backbone and the feature. It could be also common data environment of the style of Microsoft or Oracle, with then applications to be plugged in, like in our computer in front of us. It's also one language and lots of programs which are able to be run on the same system, right? So a lot of music and fantasy behind this, which brings us, even as of today, to a vast number of use cases possible along the construction site, but also for insurers in the core business or beyond, and allowing us lots of add-on analytical approaches and services, and involving further market experts, right? But last but not least, taking all this into account, these possibilities for each of the players in the construction industries and the insurers, with the focus on construction topics, a clear strategy is needed, understanding clearly the purpose of each of the IoT applications, and also finding the, let's say, the killer use cases which are critical then for pushing IoT more in the future. And last but not least, taking into account all existing capabilities in the market, but also in the company, in your company, to increase then also the probability of success. So in a nutshell, happy to talk to you about the construction 4.0 developments, IoT growing and driving the digitization of the construction process, but also in the buildings in the future, and a lot of potential for insurers in this game. Any questions?
Thanks very much, Carsten. I can't see any question in the chat, so I think we can unmute all the participants to engage the lively discussion. In the meantime, I have one question regarding some types of the project. Can you please give us some examples of application of IoT in modular construction? I mean that this is very important now, because a lot of markets are starting this, and the market is growing. So maybe it would be interesting to discuss some live examples of application of IoT in modular construction.
Yes, happy to do so. Remember my 4 process steps around a construction project: production of material, distribution, construction itself, execution, and facility management. The modular construction is a nice example how much this results in a flow of material. It's not concrete which is produced, but it's the module which is produced, right? Why is modular construction so trendy currently and will be the technology of construction in the future? It's purely because of lack of labor on the construction, especially in Western in industrialized countries, the lack of labor workforce, but also the cost of labor force, which makes then modular construction, bringing the originally in situ construction back to an industrial site, right? Exploiting then potentials of efficiency better. This is why modular construction is coming up now and is developing fast. And if I now come back to your question, what can be done with IoT? It's first of all identify the origination of each of the modules which will be assembled in a building, right? Because it becomes more and more important that the quality is guaranteed, not only during the execution phase, but also in the future. That at the end of the day, you know exactly, maybe based upon your digital twin, you see, wow, I have a wall breaking away, right? And you can automatically see where this product comes from, where it has been produced, and correspondingly also direct your claims towards the correspondent supplier, right? But if I follow these process steps more, these modules need to be transported, right? It usually bypasses then the wholesale and they go directly on a construction site. And when we talk about efficient construction, it's also about just-in-time delivery of these modules, right? You build floor per floor, so no need to start with modules which are planned for the 15th floor. We start with modules at the beginning, but no need to just park them on the very dangerous construction site where the cranes and the excavators might break products. No, based upon IoT, they are steered just in time. You know exactly when they are being built and when they leave the factory, where they are by GPS, when they arrive on the construction site, and all this fits your current planning to build floor per floor with the corresponding modules, and then you build up the structures, and then you want to go for the technological equipment, sanitary, electricity, etc., and possibly also by bath pots, right? Modules with baths, exactly delivered on time there as well. And then on the execution, on the construction site, again, all what we just said is valid here as well, that within the modules and the technologies, we use sensors of all kinds to enable them to fit in the construction phase, but also to enable them predictive maintenance at a later stage. And then it comes to the facility management step. And there, I think, no big difference, only that we are not talking about the work of a construction or a general contractor on site, but a multitude of modules which has been bought, distributed, delivered, and assembled, which needs to be tracked and which needs to be maintained, and where predictive maintenance is needed, and which at a certain time might be needed to build back, right? Module per module, knowing exactly what kinds of materials is in there to then optimize also the second life, either of the module or of the rest of the building. So a lot of potential in IoT and digitization also along modular construction.
Thanks very much.
Yes, and maybe one thing or two things to add on this. Of course, if you're going for modularized construction, that is moving away from just building individual units over and over again, which has a stronger case to apply IoT from the beginning, because you can scale the original cost that is driven by setting up such a system and designing an additional feature of the model. And of course, it also makes it easier to manage a bigger liability, because if you're producing the same thing over and over again and have the same mistake everywhere, of course, it has even stronger case to monitor and supervise that based on IoT from an insurer's perspective.
Thank you. Any other questions? You can write them down in the chat, or you can turn your sound on and ask the question.
If not, it looks like the topic was very clear. They are still fully muted. Stephanie, can you possibly unmute everybody?
I will try. Sorry, guys. Turn off incoming video. It's not clear how to unmute people in the middle of the session. Someone. Don't worry. Probably no further question, he said. Oh, there is a question coming in. Would you like to read it, Marina?
It's a question from Andy Kane. What are the barriers to adoption of IoT in the construction industry, and why do certain territories lag behind?
Yes, that's a very good question. I mean, it's not only about IoT, but digitalization per se in construction, right? I mean, definitely the usage of IoT and digitization as an innovative measure is depending on, let's say, digital affinity of cultures to this. We see that building information modeling and digitization has developed nicely in the UK and Scandinavia, even in Singapore, to mention there that it was made that it was regulated also by state. By the way, BIM is often regulated by states to be used in plannings of public tendered projects, and this drives then all this digitization on the construction side, also in the states, of course. Also home country to Autodesk and a lot of very famous startups in digitization of the construction industries. And then finally, when we come to Central Europe, it's not a matter of industrialization, it's a matter also of construction culture. In Germany, for instance, digitization is comparably still quite behind Anglo-Saxon companies. Why that? Because I think in the classical construction culture, there are some which are more down to earth, and also craftsmen, subcontractors, and mentality maybe still a pre-digitization generation, which we see is changing now and is driven then by really the digital natives, the new generation. And we see this now also even in Germany, but also in Eastern Europe. It's picking up, and it's picking up very fast, and coming also to a level of the previous digital native countries. So that's a bit the reason why it takes some time, a bit longer here and there. And secondly, of course, it has also to do with investments in this digital means. this professionalized construction costs, which then become more to emerging countries, is not yet undertaking these investments. So that's a bit the 2-3 drivers of why IoT is here and there slowly penetrating the construction industry than elsewhere. I hope this answers your question. Let me see one further question, I think, from Marcos, right? Does IoT possibly increase the danger of cyber attacks on project? Usually a lot of projects are offline for most of the construction period. What happens if a cyber attack occurs to the digital twin, changing certain figures or calculation? Very interesting point, yes. I think the cyber attacks here even more dangerous than in other industries because as I said, the construction industry is very new to digitization and thus are not yet enough prepared to all kinds of cyber attacks, so are more vulnerable than professional, I don't know, automotive or financial banks or insurance, right? Which have departments, which have hundreds of people just taking care of data and security of data. And imagine a big project, a construction project. I guarantee there are possibly up to 30, 40 different subcontractors being on site, and the security certainly gets lost today somewhere in between the architect, the general contractor, and some of the subcontractors of a subcontractors of a subcontractor. So definitely a big risk, Marcos, which needs to be tackled.
Yes, one more thing to add, and that also relates a bit to the previous question on what's preventing the uptick. Regulation, because if you're a bank, you are regulated in terms of how to protect your own networks. The same holds true, of course, for insurers. Whoever the regulatory body is would push you to protect the data and reduce the risk of cyber attacks. That is something the construction industry is not. And that's why there is a higher risk of cyber attacks for sure when they start to build up IoT-driven networks. It's different if you put up closed systems just on the construction site where there is no external points to enter. Of course, that is then really the question of how to design it. But I would see this whole discussion more in the realm of how to reduce the risk. Then again, per se, I would also say there is a risk. Yeah.
There's also an interesting question from Cedric Wong, about data sharing of construction projects with insurers. As we explained, this digitization and the single source of truth, thus the data pool behind all these projects, is still very new. But in an ideal world, depending on the size and the involvement of the insurers, I'm speaking loud out my question and possibly potential use case. The insurer gets access to the BIM data, right? If he's the one who needs, he's insuring all the process, and thus either by own analytics and arithmetics can assess from quality of the building and the planning to then quality of the delivery and the execution on site, to then in the facility management world, to the right usage of IoT and sensor technique. This would be an ideal world to get access to the data, which certainly is still quite far away, but it could be a way in making this either mandatory or in another case becoming the single source of truth of a construction site, right? Offering BIM platforms for construction with use cases which fulfill all needs for insurers, right? That's a bit a potential terrain of activity.
I mean, there is also the follow-up point from Virginia, I think is the first name, that this sensitive data might be very useful to analyze responsibilities in terms of claims. Yes, I would definitely agree that this would help to analyze and also speed up and accelerate the claims process. But at the same time, putting yourself on the shoes of the customer, the question is, do you want, per se, the insurer to be able to use this data to do such an analysis? They might also be a motivation to keep that to themselves and steer that process, let's face it. And then in the end, the question is always, and that is a very individual one to resolve, I guess, to have a structure that is beneficial for everybody. So you have to be able to explain also to the customer why you want the data and in how far it helps. And that could be, okay, we can guarantee you a more speedy claims regulation, up to we are able to use a parametric solution if you provide the data, because then you can skip the whole claims analysis process if you have a clear parameter on it. Same time, you could also use an argument, okay, we're giving you better tariffs in case you're providing the data, because you yourself believe in the data being helpful to mitigate a risk and reduce the expected claims. And that always has to be a bi-directional discussion. And if there is a clear case also for the customer, then there is a good chance to get the data, but the case and the rationale has to be there. Yes, I mean, that is more or less what Miguel is just saying, I guess.
Yes, yes.
Yeah.
And I would agree on that one. It's just, you have to explain people why you get the data. And that is the same situation in many industries, where we always face this this discussion, who has access to which data, and you have to be able to explain why you need it. And that is also, it's also helpful on the insurer's end to be able to explain, because otherwise you're collecting data and put effort in it and you don't use it, which is also not really in anybody's interest in the end.
I think we also use more and more IoT, for example, for some long distance construction site. I mean, just simple having a web camera turned on give us not the whole information about the project, but a lot of information about how things are going on, about the weather. So it would be used not instead of risk survey, but in order to help the risk engineers.
Yes, I mean, that is a point. Maybe that was not clear enough in the use cases. We definitely don't want to say all this has to be sophisticated solutions with a BIM model spanning like multiple square kilometers. It can also be very simple solutions, very simple ones. For example, the wearables topic we had before, it's just monitoring body temperature and heart rate can already help you to mitigate the risks and help on the construction side.
Yeah. Also, maybe the other example could be to use some kind of web cameras in the places where we cannot install some kind of fire alarm or fire extinguishers, just to monitor the place.
Yeah. And we also when we did this in more detail, we also discussed about drones, just doing one round across the whole site. And you see when the fences are down, because if you have large construction sites, there is fences to protect it, and you have an issue when they are not there anymore and not effective anymore. So you just use an easy solution to check this. Also, very simple one.
Yeah. So, any other questions in the chat?
If not, we are happy to offer you whenever you have a question. Just contact us directly or link us in LinkedIn. Happy to stay in touch in whatever is needed and question is needed in your That's
Happy to do so.
Yeah, thanks very much again for wonderful presentation with a lot of examples, and thank you very much for being with us today, and hope to meet you again.
Yes,
we
would
hope
be a
so
pleasure.
too. Perfect. Thank you a lot.
Very much.
Thanks a lot.
Have a good day. Yes.
Bye bye.
Bye bye.
Right.
Bye bye.